Hello, Mr. Ryan, are you right? So what's this?
No.
Nodes? What's this? What kind of data structure is this?
Graph.
Graph, yes, G. Okay, is it a tree?
No.
Why is that?
Because it's not connected.
Well done, perfect. Okay, so this is a graph. Graph is actually a collection of vertex and edges. So the vertex, yeah, when you say the graph, yeah? Graph, vertex and edges. The vertex, okay, I'm gonna put a 0 here. Vertex, 0, 1, 2, 3. Therefore vertex. The edges, 1, 2, 2, 3. Okay, so a graph can be directed or undirected. So is this a directed graph or undirected graph? Look at this. Directed means with the edges has direction. Is this a directed graph or undirected graph?
Undirected.
Undirected, yeah, because we haven't got any directions. The number of edges connected to a vertex is called degree, right? For a directed graph, it can be an incoming degree or outgoing degree, right? But for this undirected graph, it's just degree, right? So look, the degree of this one is 1. Degree of 2 is 2. There are 2 edges. Degree of 3 is 1. Degree of 0 is 0. So the number of edges equals to the sum of all the degree of each vertex, right? Divided by 2. For the directed graph, the degree is the sum of the both incoming or outgoing degree, right? Look, for the directed graph,
Yeah.
1 to 2, that's incoming degree. 2 to 3, that's outgoing, right? Let's look at this undirected graph. Let's look at this, okay? 0, 1, 2. Okay? This is a simple graph with 3 vertex and 3 edges. So the number of edges is 3. Okay? The number of degree for the 0 is 2, right? The number of degree for the 1 is 2 edges. The number of degree vertex 2 is 2. So 2 plus 2 plus 2 divide by 2, right? Why we need to divide by 2? Look, that's a graph. The number of edges connected to vertex 0 is 2. Connected to 1 is 2. Connected to 2 is 2. So I can say the number of edges, there are 3 edges, equals 2 plus 2 plus 2 divided by 2. Why this is divided by 2? Why do we need to divide by 2?
Because it's in between 2.
Sorry, in between?
Because the edges are in between 2 circles.
2 circles.
Duh! You like, see? Like it's in between these guys. Look, this is in between these 2, and this is 2, and 1, and 2
Okay.
divided by 2, 1. Genius, mind blown.
Because I understand what you mean. Because an edge is counted twice. Am I right? Look, an edge has 2 endpoints. So edges have 2 points. When I counted this vertex, the degree, it counted once. When I counted here, it counted once. Am I right? So if I add it together, divided by 2, that's the total number of edges. Okay, so now coming back to today's question, okay, we are given an undirected graph, and we want to count the number of pairs of vertex that are unreachable for each other. So for example, like this simple graph, the number of unreachable pairs. So look, 0 can't go to 1, right? Because it's not connected. 0 can't go to 2, 0 can't go to 3, alright? So the number of pairs is 3. 0, 1 is the same as 1, 0. The number of the pairs, we are counting only distinct number of pairs, right? Okay, 0, 1 is the same as 1, 0. So there are 3 pairs, which are 3 pairs of vertex that are unreachable from each other. 0, 1, 2. How many unreachable vertex from each other? How many?
0.
0, exactly. Why is that?
Because it's connected.
Connected, yes. Every vertex can go to every vertex. Okay, another example. Okay, 0, 1, 2, 3, 4. How many pair of vertex that cannot reach each other?
0 to 3 and 2 to 4.
Okay.
1 to 4.
Okay,
Zero
so
to
look,
four,
0
one.
to 3, 0 to 4, 1 to 3, 2 to 3, 2 to 4. So how many points?
6.
How do we get 6?
By counting the.
But this is, we just counting, but is there a better way to count this? There are 3. How many connected components here?
2.
2, okay, 2. How many vertex in the first component? How many nodes?
3.
How many nodes here?
2.
How do we get 6?
3 times 2.
Okay, another question, okay? So 3, 4, 5 here. So how many pairs?
9.
9 pairs, okay. And how about this? 0, 1, 2, 3, 4, 5. How many pairs? It's hard, right?
Right, I can sort this problem. Let's see.
How do you solve this problem?
Bingo! I just got you busted.
So, okay. Come on,
Okay,
you're on
wait,
YouTube, but don't say the swear word, okay? Come
I'm
on.
not saying a swear word.
Okay.
Is that 30 compliment?
Okay.
30.
So 30. How do you get 30?
Wait, I got the answer. 8.
8.
Yes.
Let's count, okay? So we got a 6 here, right? Yeah, let's still count, right? Yeah?
Yep.
And what
5.
else can we get?
5 since nothing. But we can.
And we get a 3, 5. Yeah? 4, 5. And we get a 0, 5.
We can't
1,
get.
5.
We can't get 4,
2, 5.
5 or 3, 5 because
Why?
they're not connected.
That's right, we're counting the pairs that are not connected. So how many of these? 6 plus 5, 11. What was your answer again?
11.
11. I'm going to check the video, okay? Okay. Okay, enough, yeah? Actually, I forgot what you said, okay?
I said 11.
Okay, we're good to see you. So, do you see the
If you
problem?
don't trust me.
Do you see the problem? Too loud, too loud. Okay, so what's your thought? What's your thoughts about that? How do we calculate? This is the math question. How do we calculate? So look, we have 3 nodes here.
Dictionary.com.
We have 3 nodes, 2 nodes here, and 1 node. There are 3 groups, yeah? 3, 2, 1. When we are looking at these 3 nodes in the first group, how many pairs can we form by using the nodes here? 3. How many nodes together? 6 nodes, right? 3 nodes here, right? How many pairs of nodes connecting to the nodes in the first group? 3 times what? How many nodes together? 6. How many nodes are not in the first group? 3, yeah? 6 minus 3. There are total 6 nodes. And the nodes in the first group are, the vertex in the first group are 3. There are 3. So 6 minus 3, 3 nodes, times 3. Okay? Got it? Yeah. How many nodes are in the second group? There are 2, right? So how many nodes are not in the second group? 6 minus 2, alright? And times 2, okay? How many nodes are in the third group? 1. How many nodes are not in the third group? 6 minus 1 times 1, right? So if we add it together, we still need to do one thing. 3 times 3. 3 times 3, 9. 4 times 2, 8. 5 times 1,
5.
5. If you add it together, how many? 22.
2.
How we calculate as 11? Why is that? Why?
We divided by 2.
Why do we need to divide it by 2? Come on. Look.
Because what I said, man.
No, come on. This
Chill out, dude.
22. We need to divide it by 2. Why?
Because
Because what? Look. When I said 1, 2,
use punch.
and then 3 is 4. How many pairs?
2.
2 pairs. Why is not 4? When we count the vertex in the first group, we multiply for the number of the remaining vertex, right? But when we count the remaining, we still count it extra. So we need to divide by 2, right? Look, 1 to 2, that's a pair. But 2 to 1 is the same. So when we count 1, when we are counting 1, right? So we consider this 2. But when we are counting 2, we consider this 1 again. So we need to divide by 2. We can traverse the graph. What kind of traverse diagram can we use?
Dictionary.
What kind of traverse?
Depth of search.
Depth of search. Yeah? We want to basically, we're given a graph, we want to count how many groups, right? How many groups, and also the number of vertex in each group. And then we can do the math, alright?
Yeah.
And then we divide it by 2.
Yep.
Okay? Do you understand this problem?
Yep. We just need to count the unreachable pairs on the graph.
0, 1, 2, 3, 4, 5. Okay? How many pairs? How many pairs?
1, 2, 3, 4, 5.
Do you even need to count? There are 3 nodes in the first group. There are 3 nodes in the second group. So the number
9.
is 9, right? It's 9. Okay, and add another one, 6, 7. How many groups? It's harder. It's getting harder. There are 2 nodes in the third group.
3 times 3, 9 times 2, 18.
So, okay, listen. How many nodes? How many total number of nodes?
3.
3 plus 3 plus 2.
Yep.
In the graph, there are 8. T equals 8. So I'm considering the first group now. So how many nodes, how many pairs can we form by connecting the nodes in by using the nodes vertex in the first group? So look, 3 times T, A minus 3, right? Look, A minus 3. What does it mean, A minus 3? It means there are 5 nodes other than the first group, right? How many nodes in the second group? Right? It's the same. 3 times A minus 3, right? Yeah, we are considering the vertex in the second group. And how many nodes other than the second group? 3 plus 2 here. 2 here. How many nodes are in the third group? 2 times A minus 2, right? Look, so by if we are adding these together, what's the answer? 3 times 5, 15. 15 plus 15 plus 2 times 6, 12. But we have to divide by 2, right? We talk about that. Why we need to divide by 2? When we talk about this, the vertex in the first group, we connect it using to the second group and third group. Now when we calculating the second group, we connect it to the first group. Look, and that's double counting. We count it twice, so we need to divide it by twice. So that's 42 divided by 2 is 21. There are 21 pairs. Got it? So our approach today will be depth search. So we depth search the graph, then we count how many nodes in each group, right? And then we do this math. And we can also use the breadth search and union count. Yeah, we're going to talk about in the following few days. This is very important. Define the count. We are given n nodes from 0 to n minus 1, and we can given the edges. We can convert these edges A to B. If this is undirected graph, we can convert it to an adjacent list. Okay, G equals default dictionary, and it's a list. Right? So for A, B in edges, GA dot append B, GB dot append A. Okay, there's an edge coming from A to B. It means that there's an edge coming from B to A, right? So look, 0 to 1, 2, 3. Right? If we have this kind of graph, the G, this is a dictionary. The G will be a dictionary of what? 0 will be to 1, 2, 3. Okay, and then 1 will be 0, 2 will be 0, 3 will be 0. So basically, the keys are the vertex, and the values will be the list of vertex it connects to. It has these edges to. For example, 0 has the edge to 1, 2, 3. 2 has the edge to 0. Okay, this is called adjacent list. Okay, this is a data structure. Now we have this G. Then okay, obviously we want to have this answer equals 0, and we want to perform this depth search and breadth search in the graph. We need to use the hash set to remember the nodes we have been seen. Okay, so seen equals set, and then we're going to define a depth search common node I. If I in seen. So this depth search function will return the number of nodes in the current group, from the I. So if I in seen, then we need to return 0. And the first thing, if not visited, we need to add it to the hash table, to the notebook, right? And then A equals 0, A equals 1. There's at least one node. For I in GI, we're going through the vertex it has edges to, then with A plus equal depth search recursion I, right? And then return A. Okay? And then we can go through all the vertex and count how many nodes, right? So for I in range n, okay, now we have this if I not in seen, Right? If we haven't seen this before, we want to count how many nodes is it. So C equals depth first search I. So C equals depth first search I means that the number of nodes, the number of vertex connected to vertex I. Then we can do this. I'm writing here. Yeah. Answer plus equal C times total n nodes, n minus C. Right? And then at the end we return answer divided by 2, okay? Or answer shift 1 or divided by 2, okay?
Yeah.
Can you describe to me what have you learned today? What's the problem? What have you learned today?
The problem
Counting
is
is there is a graph.
There's a graph, yes, very done. What kind of graph? Is it directed?
Undirected.
What's undirected?
it means it doesn't have any direction.
It doesn't have any direction,
Yeah,
okay?
the common sense.
Okay, common sense. Okay, so we are given an undirected graph, and what are we doing with it?
We are trying to figure out
Count the unreachable.
nodes.
Unreachable pair of vertex, yeah? So how do we do it? What's the mess? Okay, so look, 0, if the node, 0, 1, 2, 3. How many pairs of nodes without any edges? How many pairs of nodes that are unreachable? There are 4 nodes with no edges at all. How many pairs of nodes?
Let's see.
So how do we calculate?
Wait, I'm just so confused, man.
0, 1, 0, 2, 0, 3, 1, 2, 1, 3, 2, 3, okay? Basically, it's like picking 2 out of 4, yeah? Okay, that's 6, yeah? 4 times 3 divided by 2, 6 pairs. Bless you. The number of unreachable
16.
pairs,
No, wait.
I just told you 6.
Oh,
Yeah, the number of unreachable pairs in the same group is the same, right? It's the same. Why is that? Look. Why is that? 0 and 1 connected. 0 and 1. And then here is 2 and 3 and 4. Look. So 0 can form 3 pairs. 1 can also form 3 pairs, right? Okay, so coming back to this question, what's the algorithm we use today?
Depth of search.
What are we doing with the depth of search? We want to count how many nodes in.
and then divided by 2.
Look here, doing depth of search. How do we depth of search? We want to depth of search returns that this has 2 nodes, this has 3 nodes, right? So how do we get the numbers? 2 times 3. How do we get the numbers?
We times them.
Yeah. Look, it's 2 times 3, and then here we will do this, and it's 3 times 2. We add it together and divide it by 2, so that's 6. Got it?
But why can't you just do 2 times 3?
Exactly. That's a good question. Why? Yes. So in this algorithm, we are going to the nodes 2, yeah, and then we count 2 times 3. But we need to go to these nodes again and 3 times 2. We add it together. We
But
divide
that
by 2.
doesn't with
This-
the time.
If there are 2 groups, you can do 2 times 3. But the thing is that another group here, 5, 6. How do you do it? How do you do it?
Using your brain.
How do you do it? So you just say 2 times what? 5. Right? There are 5 nodes here. 2 times 5. 3 times 4. 2 times 5. You add all these together divided by 2. Got it? Yeah, because when I talk about this 2 times 5, this has been calculated once, yeah? Okay? When I talk about this 3 times 4, this has been calculated again. So the connection between these has been calculated
But
twice.
what's about like this 2, this 5, and this 2, this 5?
Yeah, so everything is counted twice. That's why we add it all together divided by 2. Make sense? Do you see my point? I talk about the number of edges. Look, 0, 1, 2. The edges has been counted twice, right? Look, 2 edges here, 2 edges here, 2 edges here. 2 plus 2 plus 2 equals 6. But how many edges here? How many edges? There are 3 edges. So 6 divided by 2, okay? Okay, that's it for today. Bye-bye.
Bye.